Hello. I put this together about testing website search, something that we used to do quite a lot of focus on at OpenSource Connections, and I still believe is a really important thing. It's amazing how many clients I talk to as a consultant, and I say, how do you know if search is any good? And they go, we know people don't like it, but how do you measure how good search is? And that's something I think is really important. This is me. I've been doing search for a very long time. Most recently at OpenSource Connections, previously a company called Flax, so I co-founded, and Alan was one of my colleagues there. So going back in consulting back since around 2001. I've run conferences, I've co-written books, I write a lot and talk a lot about search, and I really do juggle. I've been doing that for almost, in fact, longer. So if you want to find out more about me, do check these things out. My wife doesn't like the picture, thinks I look old. Not my kind of picture.
That's black and white.
Yeah, that's why I look old. That's in the 1950s. Anyway, what I'm going to cover today is a little story about getting started with measuring search, why you might want to do it. I'm going to talk about a tool called Cupid, which is a way of collecting human judgments to measure search quality. And then the hack I've made to make it work with pretty much any websites for the search function. I'm going to do a live demo. And then I'm going to talk about, well, actually doing human judgments of search quality is really boring, so let's get AI to do it instead. So let's start off. Jed. Jed, I'm going to call them Jed clip art. Has just started work at a company called Superco, and Jed has been given responsibility for search quality. So Jed is maybe a search product owner. There's some different terms for this, but somebody who's basically accountable for how good search is. They've heard there's some problems and some complaints, but how hard can it be to improve search? And so Jed realizes their first step is to try and work out how good or bad search actually is. So Jed starts looking into the feedback Superco's had for search, and it's not particularly pretty. People are getting blue things and searching for red things. People are searching for the product and only getting the accessories, not the product itself. People are going to their competitors, and strangely, there's no positive feedback. I don't know if anyone else has experienced this, but very often when you ask what feedback do people get on their search engine, they get the negative stuff. Nobody actually sends you an email saying how wonderful your search was, which is a bit sad, but that's the reality. So Jed tries some searches, and it's quite obvious the results are great. They don't really know much about what Superco sells, so they're not really sure about how they're going to say whether it's great or bad or middling. But they are generally thinking they should come up with some kind of numbers, some kind of metrics to say, this is how good search is today, and then maybe how are we going to improve search tomorrow. And one way of doing that is to come up with some judgments, literally to say, here's a query, here's some results. This is a good result, this is a bad result, this is a middling result, and somehow calculate all those things. So Jed starts doing this in a spreadsheet, pretty obvious way of doing it. Trying it on a 1 to 10 scale. So here's a query, and here are some results. We've done a query for red shoes, we've got red sandals, that's kind of red shoes. We've got a red dress, well, it's red at least. And then we've got a horseshoe ornament. I don't know what that is. I just made it up. But this is it's a typical list of search results from a not very good search. And that's fine. That's a starting point. Now, Jed carries on doing this for a few weeks and then ends up with a massive spreadsheet of doom. And the inspiration for this is actually a real case. I don't know if Alan remembers. Very early on, maybe about 7, 8 years ago, we had a client who was a global electronics company. And they had a team of 7 people who all they did was test search queries in 5 different languages, including Japanese, which it didn't really work with. And they came up with a spreadsheet of, I think it was around 10 or 15,000 queries. But every one of those queries was tested by hand, and then they marked how good the results were on a giant spreadsheet. And then they emailed that to the lead search developer and said, hey, go fix search. And as you can imagine, this didn't go down very well and didn't actually do much to improve search at all because it was just totally intractable. So people do try and do this. They try and measure search quality just using spreadsheets. Another way you might do it is by creating some kind of version of your website that lets you tick or cross results or thumbs up or thumbs down, some internal thing you might work for numbering. I've seen lots of ways of doing this, and it's always a bit painful. But how do you calculate some kind of overall number for how good search is, or even how good one query is? It's hard to figure that out. You just add things up and average them, I don't know. So Jed is not very happy at this point. Jed doesn't know how good or bad search is, and if you can't measure it, how can you improve it? So Jed does some Googling and does a Google for some kind of search judgment tool and finds a blog post by Mr. Turnbull, who some of you are familiar with. And Doug wrote an article about judgment lists. This is a list of, again, those judgments of how good or bad a set of results are. And that points, you can see a bit of the text from there, it points to a practice called test-driven relevancy. So you do a test, you see how good search is, you make a change, you test again, and you cycle around that, and eventually, hopefully, search quality is getting better. And it points to a tool called Cupid. So Jed finds Cupid. So what is Cupid? It was created back in around 2017, 2018, and it was originally a kind of search workbench. So if you had a Solar search engine, which is the only thing it worked with at the time, you could point this tool at Solar, you could create some queries, run those on Solar, that would come some results, and then you could make some judgments to say this is good or bad, and kind of measure how good those searches were. And you could actually change the Solar query within the tool. So I don't know, put the boost up or down, or make the initial match difference or something like this, and see what would happen, because the searches would run again, and you get a slightly different set of results. But it was very much a single user tool. It's the sort of thing you took as you were a search engineer, you go see a client, they say, search is horrible, please fix it. You say, well, where's your Solar API? Point me at this tool at it. And then off you went. Now, actually, as part of this process I mentioned with the people with the 20,000 search queries, I helped the team there, and eventually when I joined, the tool became a lot more useful for teams. So you have a group of people working on search, and multiple people contributing towards that discussion. And it began to expand to work with lots of different search engines. So as of today, it works with Solar, Elasticsearch, OpenSearch, Algolia, another one called Vector you may not have heard of. It's currently maintained by the OpenSource Connections team, led by Eric Pugh. And it's totally open source, but also there's an entirely free hosted version. So you can just jump on cupid.com and start using it today. It was something that we use all the time at OSC for all of our clients. Now, there's a few key concepts here about Cupid. We have cases. These are collections of queries. They might be 3-word queries. You know that your search engine doesn't work very well with you putting a 3-word query. So I'm going to put a set of queries together, all got 3 words, and pull out a case. Or, I don't know, queries about fish. And if any way you want to group them, this is your case. And some cases, you can have thousands of queries in the case. And bearing in mind, Cupid is a browser-based tool, that's probably not hugely advisable, but you can put lots into a case. Books are collections of judgments across a number of cases, and you can have multiple judges. Lots of people judging how good the results are from that query. Teams are those judges, the groups of judges, and the people working with a particular tool in some cases. And endpoints are how Cupid talks to a particular search engine. This is basically how it works. So you put together a list of queries, those test cases. Cupid fires them off to the Search API, and back comes some results. Pretty obvious, really. And this is what they look like. Now, if you've got it set up correctly, this set of results looks more or less like what comes out of your actual search engine on your website or your enterprise search, whatever it is. And they should be in the same order. You've got something wrong if you're not doing that. But on the left there, you can see some little boxes, and this is where you're going to have a judge say, is this a good result? So this is for washing up liquid, and we can look at all those results, and the judge who knows lots about washing up liquid, or lots about what this company sells, or lots about legal documents, if it's a legal search, can make a judgment and say this is good, bad, or middling. And you can choose various scales and scoring mechanisms. So the judge is now going to put in some numbers, and in this case, I've actually hacked it slightly to demonstrate, but let's assume that the third one is very good, the other two are better, and then it can actually total these up and calculate some kind of search metric. In this case, normalized discounted cumulative gain. And so you've got a number. We know that search is that good for that query. And this gives you a way of saying, right, we can now measure search. We've got a way of saying, for these queries, this is what the sort of quality we're getting back. Now, say I wanted to make that number better, I then go and fiddle with my search configuration or fiddle with my data or whatever I'm going to do. And then I can run it again. And I can run exactly the same set of queries again. Any items that were previously judged are still judged. You can reuse them. You might get some new results in the list if you change the configuration quite a lot. So you might have to add some more judgments, but eventually you end up with a nice set of judgments, and you can begin to iterate and improve search as you go forward. And obviously, if it comes out as a really lovely high number, you can say, yeah, search is fixed today. Well, it's not, obviously, unless you just tested some queries, but it's a starting point. And it's a very powerful starting point. In fact, if you start with as little as 50 queries, maybe cleverly sampled, maybe some from your head, some from the middle, some from the tail, it's a really good start. And you can realize how many, again, for those people who really haven't started measuring search at all, this is a really good starting point. These are explicit human judgments. We're asking people to make the judgments. Now, there's issues with that because people disagree. Not every judge will give you the same answer. In fact, the more expert people are, the more they tend to disagree. Should these be real users? Should they be people who are familiar with your product set? Should they be? There's lots of questions around this, but it's a good starting point. The other kind of data you might use when you're tuning search, of course, is more implicit judgments derived from clicks, which is fine, you get the volume, but of course, clicks have got issues as well. There's position bias. People tend to click on the first few results, whatever they are. They can be very noisy. You might have an analytics team that's an entirely separate building over there, and you go to them and say, can we have some search data, please? And they go, all stuck there. So it can be painful to get the data from them. But this is, this is a good starting point, and it's a really powerful, but quite a simple process. So Jed thinks Cupid is marvelous and starts trying to connect it to their search engine. Here is a massively simplified search architecture. Yeah, they're always a lot more complicated than that. But anyway, there's arrows, there's boxes. You get the general idea. How do I connect into the thing that's actually delivering my search results is the question here. And Cupid talks to Solr. It's familiar with how Solr APIs behave. So Jed has a go at this and then gets some error messages, and then there's stuff about proxying, and the problem is this is probably going to need a bit of developer time. And hang on, our search engine is behind a firewall because that's sensible. So I can't maybe use the host version of Cupid. My browser can't see this, and maybe I can get Cupid installed within the firewall. Well, hang on, I'm now going to talk to people about that. And they're like, what is this mad hippie open source stuff? Why are you putting it inside my infrastructure? So it gets hard. And I've seen this in reality. It can take 2 or 3 weeks just to get people to hook this stuff up. So that kind of easy to test, easy to get started with thing has kind of got away. So it's difficult. And you may not even have access to the actual search backend. There may be an e-commerce platform managing it all. There's no developers available. And all, this is too hard. And I've seen this quite a lot. So I began to think about, is there a way to make this process easier? Could we actually connect to the website or the front end, the search results everyone sees? Can we do that directly? So, first method. We know that Cupid can actually ingest a CSV file, a list of queries, documents, judgments in a pretty simple format. So could we run some kind of external service, grab all the data off the website somehow? So let's do it with some web scraping, do that. There's lots of scraping services, or we can write stuff in Python to do it. That's reasonably easy. Then you've got to take all that data that's all in the HTML and pass out the results, and then you've got to turn that into Cupid's format. And this all gets really complicated, and my Python is rubbish. So let's not do that. And also, this is a very offline process. So every time we change something, we're going to have to do the whole thing again. And then suddenly our website blocks the web scraper, and the people running our website are unhappy with me because there's a web scraper handling their front end. And this is not good. So I decided this is not a useful thing to do. The other method, Cupid has a custom search API endpoint. Now, this is designed to work with some kind of nicely described API. And lots of people have these. They have their search engine core or their cloud or whatever, and they have something on top that acts as a search API. And it's lovely and tidy and produces beautiful JSON for all your queries. And it's actually maybe a better idea because you might be doing other things in this API. You might actually be messing with the results, adding the search engine a bit, adding in some extra data. So maybe this is a bit more realistic. Maybe this is more like what the users are going to see. The trouble is, this, again, expects beautiful JSON. And I was thinking, well, can we use this somehow? Can we use this to and turn what's on the front page of the website into something that Cupid expects? So, scary bit now, lie down. I'm actually going to sit down. You can tell I'm being serious. Okay, so let's fire up Cupid. So this is Cupid. I'll come to this in a minute, but what I'm going to start off by is saying what we're going to test. So I picked the London School of Economics, purely at random, because my daughter wants to go and study politics at one university she thought about applying to, but it's literally just picked out the air. And so the first thing I'm going to do is I'm going to do a search. And I've got a search box, and let's try student accommodation. And we get some results. It's a reasonably simple, clean interface. So there we go. We can do some searches. I can look at the URL and say I can kind of figure out how I'm going to send search queries to this. So let's have a look at what's actually happening. So I'm going to bring up the debugger, and I'm going to look at what happens when I do a search query. So if I do that, oh, loads of stuff. Loads and loads and loads of requests going off. So I'm going to try and find the one that did my actual search. And I can see at the top here, there is a request. If I look at the response, I get a massive, great big pile of HTML. Now, I think I can probably work with this. So what I'm going to do is I'm going to create a test case in Cupid. Call this, second, actually sign in, right. Let's call it LSC demo. I'm going to create a new search endpoint using this customer search API. And this is where I need to get put in some kind of URL. So I'm just going to grab that straight off the LSC website, the bit before the question mark. And you can actually try and ping that. Yeah, not unsurprisingly, we're getting lots of garbage there. So I'm going to use a get. And here, where I put in the query structure, just for now, I'm just going to grab this bit where it says how I format the term. Now, this is the interesting bit. This is the bit that actually turns this into something Cupid can understand. And there's an object called data, which is all the stuff that's come back from the beautiful search API in lovely formatted JSON. Now, in this case, it isn't lovely formatted JSON. It's a great big lump of HTML. So we're going to have to do something here to turn that into something we can use. I'll come to that in a minute. We're going to figure out how to do that first. And all this, there is a way of validating this. It's not going to work, frankly, because I've got it set up right. And I'm going to put in some fields. I'm going to use in Cupid. These are ones that I know I'm going to need later. And I'll just put in student accommodation as my first query. So this is Cupid trying to do a search. And as you can see, it's not working at all. So what we're going to have to do is try and figure out how to get this data out of the website. So what I've done is, if I look at the search results here, what I like to do is just copy this somewhere useful. I've got a text editor I use called Notepad++, because it's going to be really painful to deal with it in the debugger. So what we're going to do actually is we're going to look through here, and the idea of this is to go through and try and figure out where the search results are. And somewhere in this massive pile of HTML, there's some search results. And what I'm looking for is just some chunks of code I can use to identify where they are.
You can control it?
Yeah, might work.
Yeah.
But yeah.
Just control it.
Yes. So what I like to do here is actually look at the search results and look at one of the something I've done, identify a PhD offer. There we are. So PhD offer. And there we go. And by diving into this, most likely in a text editor, I can begin to get some idea of what sort of tokens are. So there's a bit there called link, primary link. That looks like the beginning of the search results. Lots of div tokens, all that kind of stuff. Now, what I could do is use a beautiful thing to turn this all into a lovely formatting bit. The document object model, there's a thing to do that. But no, I've done a much crappier way than that. I've just used script. So what I'm going to show you is if we go to the search endpoint, I can edit this. I've got this bit of JavaScript. And this is where I'm going to try and extract the search terms out of that HTML. So let me now very quickly copy and paste in a bit of code. I've got my own function here called myExtractor, which is actually going to do the extraction. And then by going through that HTML, I need to find those text tokens and work on that data object. I can add some bits to my myExtractor function. Oops. And literally, I just create some string tokens where I know the start the results and where I know the results end. Chop that out using some horrendous manipulation. And the next bit there, do some console logging. So the interesting thing is here, once I go back and run this in Cupid, I can then use the debugger console to figure out if I actually got anything useful. This is where it takes a little work, basically just iterating through, figuring out which bit I've chopped out, have I got the right bit, have I forgotten the position somewhere. But it's just going to be a load of horrible string manipulation. And then once I've figured out where the search results are, I'm just going to iterate through the whole data. So to save time, I'm just going to paste all the code I wrote, and you can laugh at my JavaScript. Again, quick and dirty, horrible string manipulation. But it's very quick to write. You don't have to fiddle about with the DOM. So let's And basically what we do is we just iterate through our results and add it back into an object that just gets passed back to Cupid. And then Cupid's got nicely formatted, tidy results. You can see down here, you can see the objects that Cupid expects. Literally, ID, title, URL, summary, you know that when I say up. So I'm going to share that endpoint. I can now go back to my page and see if it works. Yes. So for our query student accommodation, we've got some results. And as you can see, the results look a bit like they did on the LSE website. Now, there's one thing that's not going to work, which is the fact I've hard-coded the query. And I want to add another query. I'm just going to paste in the magic token that Cupid uses to this. By pasting this in, it means I can put other search queries in and build up my test case. That should work. Did. By parking. As you should be able to see, I've also got some results for parking. But I think you can also see, I think the LSE need to work on the search a bit, because that's not great. Lots of the same results. Lots of weirdness there. You've got to use the console debugger a lot to make this work, frankly, because it's a matter of iteration. But I've tried it on quite a few different websites, and it's a very quick and dirty way of getting results out without understanding at all about how they're presenting the results, how they're delivering it, the front-end tech. Doesn't matter. We're literally just doing horrible stream manipulations.
Did you try ChatGPT or other AI tools to pass?
Sorry?
Did you try ask ChatGPT or other AI tools to pass the results?
No. So this is far simpler than that. We'll come to something about AI in a minute. I know people want to talk about AI. So now what we could do is we could go through and we could start making some judgments. We could say that actually I'm going to change this. I just changed the score on this. Let's use a 4-point scorer so we can generate some NDCG numbers. So we think this one's fair, this one's poor. And we could go through and score all these and basically eventually generate a nice number for how good we think search is for the LSE website, etc. And then we can try and tweak search and improve our number. Okay? Right. So, very quick and dirty. Connected Cupid to the search page of the website, picked the website randomly, managed to send some queries to the page, got back the HTML, put them into Cupid format. Now, there's an interesting thing here, which actually makes it better in some cases doing this than talking directly to Solr, because Solr or OpenSearch, whatever the search engine is, because we are seeing exactly what the user sees. So if in some of the code above the search engine, there's some kind of manipulation of the results or some extra stuff added in or whatever, or re-ranking, we get all of that as well. And if you're testing search, you don't want to be testing something the user isn't also experiencing. You want to be testing what the user sees, because that's what you want to improve. So how can we make this better? Firstly, write better JavaScript, as you can no doubt. We could use the DOM parser and get beautiful structured data out of this. There's another cool feature with Cupid is if you can get pictures, you can show them in the search results. And that's really useful as a visual cue when people are judging search results, especially on something like an e-commerce site. Now, the LSE has not got any pictures, but on lots of other sites, they have pictures of products and things like that. So for judges to be able to measure it, it's much better. There's almost certainly many other things we can do. But there's a small problem with manual judgments, which is they're not very exciting to do. It's not fun for you in the search team. It's not fun for the people you've got to do the judging. If the people you're trying to get to do the judging are experts, say if you're running a legal search and you want to pay lawyers because they're the ones who know that's a good result or not, their time is really expensive. And this is often the problem with teams, is scaling up this kind of manual judgment process. It's great you've only got 10 queries to test, but if you're suddenly testing 500 queries every week, you're in a bit of trouble. So it's hard to scale. But something very recently added to it is a way to get OpenAI to do the judging for you. Or actually, you can do it now, any with an OpenAI, a compatible interface. And the team, I mentioned earlier, the team of people doing the judges, you add an AI judge to that. Now, there's a caveat here. Do we trust LLMs every time to do everything? We should probably validate this with some kind of ground truth to make sure that our judges aren't just making stuff up. But in my very limited testing so far, it seems to do a pretty good job. So, AI demo time. This is much quicker than the other one. Glad to hear. So what we're going to do now is we are going to share this case with a team. And we are going to create a book. A book is a collection of judgments. Let's call this LSE demo again. We have to create a book so we can get let's pick the same score as we had before. Selection strategy, we're going to let multiple people judge each result. And we can create that book. And now we can add a AI judge to it. Now I've created an AI judge. It's just an OpenAI judge, pretty simple. Yeah. And it's literally just a matter of, telling it what your OpenAI key is. Simple as that. No one's done any judging yet, but we're going to use our OpenAI judge to do the judging. First thing we can do is look at the prompt. Just very quickly, you can see on the left, that's the prompt we're using. Gives you an idea of the scale. And also, please give me an explanation. Please give it back in a nice JSON format. Here's some examples. Any of you use these models, you probably know how the stuff works. So that's pretty simple. So let's have a go. One thing I won't do now for time reasons, but you can add extra bits to this prompt. One thing I have done is if there's a URL in the results, follow that URL and judge that as well. Because often if you've just got the snippets and you've just got the very simple search results, you don't know really if they're relevant. You may have to follow a lead to check and come back. So let's do it. Prepare to judge. That's one thing I need to do here. I can do that. Oh, yes, I have to go back and populate the. This is just copying the judgments, the case into the book for judging. More judgments are needed, it tells me. So no, no one's doing any judging. And off it goes. And the neat thing is, you can actually see the judgments it's making. And you can see why it thinks something is a good result or a bad result, whatever. Parking. Something about the governance of green spaces doesn't relate to the query about parking. There's nothing about parking, so I'm going to give it a score of 0. So it doesn't like the parking queries at all, it seems. And this will take, a minute or two. But eventually you'll end up with a lovely set of judgments. It's currently just judged 10 out of them, so it hasn't done the other ones yet. This takes a little while. Eventually it'll get onto the student accommodation, where it's got a slightly better opinion of the sort of results for that one. It's got sort of 1s and 2s out of 4. And there we go. So back to the slides. Other cool things you can do with Cupid now, you can actually get it to run these evaluations overnight. So it basically reruns all the queries overnight. You come back in the morning and it's made a snapshot of those queries to give you some idea of how things are changing over time. It's also got built-in Python notebooks. And this is useful for things like actually working out, are your judges and your raters all agreeing or not? You can do things like checkout analysis, compare results from 2 different certain configurations, what kind of conflicts they have between them. So that these are other cool things. It's become a really very useful tool. But here we go. Cupid is a great tool for gathering judgments, yes, but it is a little hard sometimes to hook up to your infrastructure. But with this, we can connect it to any website. Now, this may only be something you do at the beginning, and maybe eventually you want to do it properly. But this is a very quick and dirty way to do it. This takes less than an hour to set up for any website that has a search function. I've not found one yet I can't do this with. Somewhere in the HTML of those search results, somewhere you can put them out with a bit of horrible string manipulation. Then you do some human rating, you get some actual metrics. You've got a number for how good search is or not. And then if you're bored with doing ratings, you've got AI. And if you get this right, and you're maybe working for an e-commerce company, you can tune it for success and make some money. Thank you. So I'm happy to take questions.
Yeah, where do you get the humans from?
In reality, often it's the search team themselves are the first judges. But ideally you should get someone who's a subject matter expert, understands, is this a good result for the query? For example, if you don't know there's a better result, if you don't know the product set or the details of the content, you may not make as valid a judgment. But in reality, often it's the search team start doing it and then they try and find some willing victims or volunteers. Or you might have some tame users, or favorite customers, things like that. And I've seen people say, a bottle of champagne, first person to rate 300 documents or something like that. There's ways of doing it for the social engineering. But the good thing is, once you've done your original set of judgments, there's a decreasing amount you need to do, because as your search gets better, you're going to get fewer and fewer entirely new documents turning up, unless your content is changing rapidly. So there's things to play with here. Yeah. That's good. Anyone else?
I see that it's designed for HTML, processing HTML, but the search and filtering, I think it works for other documents as well.
Well, this should work with pretty much anything. I mean, if you can throw a query with an API, whatever it sends back, you should be able to pass it this way. Again, this feature is designed for nice tidy JSON, but not have to do too much to it. But this is just grabbing whatever comes back.
I've got a question. It's probably not for you, Charlie. It's for the OpenSearch people in the room. So I think it was 2.13 of OpenSearch brought out a thing called the search index tool or the index search tool. So if you take the point up until you're doing the judgments and the AI, the question is the search index tool, is that similar to Cupid? Is it complementary? Is it totally irrelevant?
You mean the search relevancy tab, right?
No, there's a thing came out in 2.13 called the search index tool.
Is it a repo inside the
Yeah, and you can do queries inside OpenSearch. Am I the only person in the room who knows about this?
Yes. Are you sure you don't mean the user behavioral insights? Is that something similar to what you were talking about?
I'm looking at a thing on OpenSearch.org that says search index tool introduced in 2013.
All right.
That's a type of flow agent.
Charlie, well, while they're discussing that, what do you do about missing documents? So if your search is so bad that actually the best ranked document doesn't appear,
Yes.
you can't score it because it's not there.
Yes. There is a way to deal with that, I believe. If I go back to the case, I think there's a way to do that. Yeah, there is a missing documents feature here. There we go. Okay, so you can say, you know where it is, you can give it a rating. Do
you have an answer? Or?
I don't.
Well, there you go. I broke it.
No, but maybe the answer is not equivalent to this one.
Yeah, this is my
completely
question.
different.
Is it different?
It's
Is it-
completely different.
is it-
That much I can tell.
Well, I will say that, Cupid's not the only tool that does
Sure.
this kind of thing. There's a relatively new one that's just come out, which has got much more modern UI. His name escapes me. It's a German guy created it, like EPAM. There have been other tools that are kind of doing relevance judgments, including the ranking evaluator, the C's team. And I know that OpenSearch in particular is adding various features around this kind of search testing, which they're doing, often in concert with some of the OpenSource Connections people. So it's a lot of the same people working the same angle. But I think Cupid's been around the longest so far. It can be a bit fiddly to get your head around sometimes. It's not got some of the UI elements are a little hard to work with, but it does the job.
At some point, we were discussing about having Cupid with a tight integration with OpenSearch.
Yeah.
So if there is a plus one on it from one of you all,
Yeah.
we can make that happen.
That
That would be nice. Yeah.
would be nice, yeah.
Thank you. I have more original question. So I see you have got 2 queries here. So in your experience, about how many queries do you expect to test with, so you don't end up tuning to only 1 or 2?
So that's one of those, how long's a piece of string questions. I think to start off with 50 is not a bad start. The question is then which queries? So should they all be the head queries, or should they be a mix? So there are some approaches. There's a probability proportional size sampling. Is that the technique? There is a way of basically sampling all of your queries from your logs to get a certain representative set. I think there's a link somewhere in my slides, which I'll put up in the group to a blog post written about that. But yeah, I know teams who are testing like 1,500 queries. I know some are just testing 100. A lot of it sometimes, you have a particular problem, you set up a test case for that problem, you fix that problem, and you set another test case for another problem. It really depends on the process you're working with. Okay. So yeah, this approach is very much for the kind of getting started phase. As you go further along, you might end up with a slightly more complex way of testing queries with a wider set or a more focused way of picking them. But yeah, I do know Cupid is used for some quite big query sets, and it does work. It may take a while to run through them.
Yeah. How about testing for capture images? Some search function says capture image, and is it possible to also integrate that kind of scenarios?
So a search function like
capture images, like I'm not robot tip questions. Capture. Yeah.
captures.
Yeah. Is there an option that everyone to like
What protection?
Yeah.
Protection on website?
Sorry?
What protection? When you get hit with a recapture, like a
Yeah.
I guess you ask me how can this bypass that?
Yeah, that'd be an interesting one. Yeah, yeah. Considering those things are meant to stop people bypassing things, I don't think AI is the answer either. So yeah, don't know. The websites I've tested with this have been pretty free and easy and open to everyone. But yes, if there's something stopping you doing automatic things.
If you're on the website, you can have whitelists that.
Yeah, but again, whitelist is one of those things you're probably going to have to get someone to agree to do. This, I mean, I didn't ask the LSC, but it's quite nice when I talk to a new customer to run this up, and I'm already showing them numbers about how bad the search is. And speak to them, it doesn't require Okay, I think, shall we have a little break for a bit more pizza and a drink and then come back with our second speaker? How would that work for you, Nate? Yeah. So, I think I should grab some pizza and grab the drink. We're going to our second presentation of the evening. Mr. Nathan Booth.
Thank you, thank you.
From the OpenSearch project, and he's going to be talking about index state management. Great. The floor is yours.
Appreciate it. Well, thanks for having me here, everyone. I'm going to invite my OpenSearch friends here to chime in just to keep me honest in case I get something wrong here. I've done homework, but it is not always perfect. So the feature that I'll be talking about is called index state management, and it's specific to the product OpenSearch. I would not be doing my job if I did not inquire of everyone. Does anyone know what OpenSearch is or have heard of it or anything like that? I see a couple of nods. Okay, a few hands. Wonderful. Okay, so I'm not totally out of my element here. So anyways, I'm going to spend a few minutes talking at you about index state management. And like the slide says, it's a way to automate the things that keep your cluster healthy. So I'd like to probably start by relating a story, which is probably indicative of my personality. But when I was learning OpenSearch, it's an indexing database. So the idea is that you ingest a lot of information into it that you want to search through. And when I started, when I finally got it working and I was putting documents in there and being able to search through it, I got really excited. And I had set up workflows to put logs in that I could just fire and forget and just let it fill up. I was so excited that I learned very quickly why index state management is a good thing to learn how. What I saw happen was that my data lake turned very quickly into a data swamp. And that is because I was not automating any of the operations that I should have been. So I'll probably be talking to you today about the specific feature on OpenSearch that will let you do that and some of the ways that you can implement it. Sound good? Yeah. Okay, we're all here for that. So I'm Nate Boot. I go by Nate. What they call a developer advocate, which I refer myself as a digital cheerleader. I try to get everyone engaged and excited about OpenSearch, and hopefully that leads to people getting interested in the project and contributing in one form or another. Not necessarily money, but code or documentation, blog entries. Those are all things that we would love to have any of the general public contribute to our blog. So even if you think you just have an interesting opinion on something, or you just learned about something cool, come to a community meeting and tell us all about it. Just show and tell. That's how we build communities. I'm also a dad joke specialist. I will spare you tonight, but if anyone wants to share a few after.
Or dad jokes.
Yeah. All right. So why is it important? Of course, one of the things that I talked about is that my collection of data as I was importing logs, it got stale. It got kind of weird. It was hard for me to find things. So one of the reasons that it is important is that you get to automate the things that keep your data healthy. The other thing that I found that was important is, well, suppose you're not running it on your own infrastructure and you're using maybe a cloud provider. It is sometimes the only thing that keeps you from waking up to your bill jumping by a couple $1,000 because you've got so many documents in. So it's good reason to make sure that your data isn't increasing ad infinitum until your bill is a big surprise. No one likes losing money. So that's one of the reasons why it's important. So the basic components of an index lifecycle policy, it's built of three things: states, transitions, and actions. So they execute pretty much in this order. When you build this policy, you define various states that they exist in. Every state consists of a couple of actions that are performed one after another, with pauses in between that you can define. And if one of them doesn't work, you can tell it to retry a number of times, how long to wait before retrying those things. And then conditions by which they will decide to switch to another state. And so I don't know if there's a limit on the number of states or actions that you can have in a life cycle policy. So the sky is the limit for now. If someone does find a limit, that would probably be something we'd like documented. So file an issue. I would not be doing my job if I didn't ask. So actions can be a lot of things. Right. So those are the three things. The states are what they sound like. They're the various names. They could be anything you want. You could just smash your hand on the keyboard, and that could be the name of your state. And then when index enters a state, there's a number of actions you can perform. This is an exhaustive list. I won't talk about every single one of them right now, but we'll peruse them very briefly to see which ones might be the most useful. And so I can pretty much point out without much hesitation and tell you that usually the most helpful are roll up, snapshot, roll over, and maybe delete. Sometimes shrink and force merge are helpful. So if we get time or if anyone wants to ask afterwards, I'm happy to discuss at length those things. But those are usually the most helpful things. As I was preparing for this, I noticed that one got added to our documentation that I did not have. So this new one, convert index to remote. One of the things that we allow for at OpenSearch is to have an index kind of live somewhere else, like on S3. You can have remote storage options. And so if you want to convert something from a local to a remote index, that's one of the things you can do. Not immediately interesting, it can be a complicated use case. So the transitions that I mentioned, you define these conditions pretty much. There's a number of conditions you can have. A minimum size. So in my case, what would have helped me is if I had said, if my index gets so big that it exceeds 30 gigabytes or X number of bytes, for it to enter another state that performs some action like a roll up or a rollover, even delete if it's transient data that I don't need again. Minimum age, so that's another common one. I'll get to a minimum age one as I go through some. I have names for some very common collections of actions that I tried to be as clever as I could to share them. So you'll see them in a second. So minimum document counts. So one way to keep them clean is to make sure that your indices don't go over a certain number of documents. And so this is just a couple of the ways that you can define transitions to move between the states. So these are my favorite examples. Snapshot, then delete. So when you take a snapshot of an OpenSearch index, you're just kind of taking all that data in the index. Say that you've got a search engine that's got all of your website's content on it, and so you have a search engine that searches through your website. So the index that holds all of your website's textual data that you're searching through, you can just take a snapshot of it and move it somewhere else if you don't need it anymore. So that's a very common one. The one that I call this one the Fido, because it's a dog's name. Roll up and then roll over. If you're not familiar with a roll up, so suppose you've got an index that has metrics or numbers of some kind, and you decide, well, I don't really need the actual numbers themselves. What I'd like to do is store the aggregations that I've made on these and then just kind of shrink it up. So a roll up lets you get rid of all of the source information, but then leave some metrics behind. The mean, the average of this particular field. It might be the number of bytes. If you're recording network traffic, it might be any number of things, any metric that represents numbers or any aggregation that you can perform. It will just kind of erase all of the source data that you ingested, but then leave behind just these aggregates. And that's a way to save room on your cluster. And then the rollover is if you have an alias for an index, so you can you can have kind of a keyword or a code name for an index, and then change the one that it points to. So like if you, a good example of this is like if you're ingesting logs for your website, you might want to separate your logs into indices that are named after the year, month, and day. So you might have weblogs -2025-01-05, or I think you do it 0501 your month day. Is that right?
That's about right.
Yeah.
Right.
Yeah. Yes. Out of my element here. So anyways, you could set up an alias that just says weblogs, and then have it point to the specifically named index for that, so that if you have software that writes to these, you don't have to change your software. You write to this alias that points to the index named for the day, month, the year, month, day. So I call that the roll up, then roll over. You roll up those statistics and then roll over the index, so that the index behind the alias is actually a new one that represents the new day or month or year. Similar to that, I call the honey, I shrunk the index. I might be aging myself. Have we all seen Honey, I Shrunk the Kids?
Yeah.
Okay, I needed some nods, thank you. So that we shrink the index. I might need an assist from the team here, but my understanding of a shrink is that the indices, all the data in the indices are in shards or segments. You know, they're kind of in pieces, and you can gain efficiency either by having them use more shards or less shards. But a shrink will cause the data in an index to use as few as possible. So it shrinks that data into as few segments or shards as possible. And so most people do that for query efficiency. You know, if you're a common practice is to you know, run your most common queries to warm up an index, and if some of them are taking longer than they should, you have to look at these kinds of metrics to make sure that your queries are running quickly. So shrink and then perform the FIDO, the roll up and the rollover. And then my favorite for for data that is not important whatsoever, you're just playing with something, is the self-destruct. You can have an index that deletes itself unconditionally after 30 days. Not recommended for important data or anything someone else might want to look at later, but if you're just goofing around and you're thinking, in a month, I don't care about it, you can just have it delete itself. So those are some common ways to implement those. If I'm good on time, I might show you the UI where we can see where some of these are defined. When I showed you the list of things that you can do to an index, one of them is snapshot, and that's mostly a backup kind of a thing. You know, it takes your index and stores it somewhere else for use later or for a restore later. We also have the concept of a snapshot policy, which is basically the same thing, only it doesn't quite live under the same roof as a index state management. So snapshot policies are basically index management policies that just snapshot at certain time intervals or at regular intervals. And so there's a time and a place for either of them. And I wanted to mention snapshot policies because invariably I get asked, well, why not just use a snapshot policy for your backup? And so there is a place for those. So the place where you'd want to use index state management policies is, well, of course, when you want to do more than just a snapshot. So that really brings me to, like, we're automating the things that keep our data healthy. And so snapshotting isn't necessarily a means of maintaining health. It's a means of backup and restore. It's disaster recovery. It's, you know, we need to restore something. So index state management is for when you really need to maintain the health of your data. Snapshot policies are just basically, it's a very, you could consider it a very simple index state management policy, and it's mostly for backup and restore, retention management, etc. So, and I hope that illustrates a bit of the difference between the two when you might want to use the one versus the other. Am I getting through? Is this, we scan? Okay, nods, awesome. So yes, it's not just a feature, it can be a lifesaver. It can save you dollars out of your pocket. It can save you sanity when you're trying to keep track of what data is in which index. So, if you automate these things and make sure that you're keeping them clean, it's always best practice, because if you end up with 7 years worth of web logs in one index, it's going to be very inefficient to query it and to make much sense out of what's in there. And if you try to run an aggregation on 7 years worth of website logs, it might take a hot minute. Just shake the dust off of all the junk that's in there. Sometimes you got to take your junk drawer and empty it out and resort. So that's really a good summary of index state management. And just to step away from OpenSearch just for a second, these are all good, healthy attitudes towards data in any information system. Once you start putting data in a production environment, it's not recommended to touch production data ever. And so if you step too quickly into some critical infrastructure without a plan to manage your data, it doesn't have to be in OpenSearch, it can be in anything. It's always best practice to have a plan for managing your data as it ages and becomes less and less important or necessary. Awesome. Is anyone, am I good on time? Do I have a couple more minutes? Yeah. Is anyone interested in seeing the UI real quick? Okay, sure. Awesome. Do my best here. What's that? Oh, you guys piqued my interest earlier. I looked up the search index tool that mentions.
I need to share that screen now.
Well, I'm reading the docs and I still don't know what it is. So I would file it, if no one beats me to it, file an issue on that, because I should be able to tell what that is, but I cannot. Anyways, leave it at that. Let me share a different window so it is useful. Starting to leak, it's a little warm in here.
There you go, you're on.
Awesome. Anything blocking the screen there? Nope. Awesome. All right. So I don't know if you've seen OpenSearch before. If you want to play with it and look around, we have playground.opensearch.org. You're always welcome to visit that. And if you want to, click around and interact with it just to see what it's like, you're welcome to do that. But the place where you will find where you can interact with those kinds of things is under index management. So you'll see a tab on the left here, management, index management. That follows pretty well, I think. And so right here, I've set up a state management policy. And I've called this one delete an index after 30 days. Or does anyone remember the name that I gave that one? I called it the self-destruct. Yeah, awesome. You guys, thank you. So yeah, here it is. Policy name, delete an index after 30 days. No index managed by this cluster shall live longer than 30 days. And so what I've created here is an index state management template. And that actually didn't go over that, but you can have policies cover indices if they match a particular naming style. So OpenSearch _dashboards_sample star, if I create any new index that follows that naming convention, it will automatically be covered by this policy. And it covers you in case new indices get added. But you can see here there are, oh, now you can't. two states. I've called this one, I have yet to be deleted. It is the initial state. It has one transition. This one does not have any actions because I didn't need it to do anything. I just needed to be in a state that represents it not having been deleted yet. So the transition trigger logic is the minimum index age is 30 days. Now, it's a bit of a misnomer, to call it the minimum index age, but these jobs that implement these transitions and actions, it's not checking every millisecond to make sure that your job is ready to fire. They run at regular intervals. So it might be 30 days and 2 minutes or 30 days and 33.5 minutes. Just minimum age 30 days. If it tries to run a job and it checks the age there, it will trigger. So that the destination state for that trigger is delete me. And so here we have the second state with one action, and that's delete. And so that's the self-destruct index state management policy. And yeah, and that's it. Was anyone curious about any of the other actions that you can perform? Or actually, let's just open it up wide to questions. Is there anything that I can clarify or answer for anyone? Not even necessarily, really, go ahead, sir.
So I have a question. How's the memory management for these operations? And
I don't think I'd be able to answer that directly. I know that if you were to try like any kind of operation that aggregates or has to go through a huge amount of data, some memory management has to happen. Since the application is written in Java, I think a lot of that would be determined by the state of the Java heap and how you configure your JDK to run. And so the more data that you're trying to roll up and save aggregations on, the hotter your engine is going to get, in so many words.
Okay.
Sure.
Is there a follow-up? Is there any way to track the completion of these? Potentially they last.
Yes, that's a good question. So there's one of the actions that you can add to an index is an alert, but you can also set up a destination for notifications if one of your actions was to fail. So if you tried to delete it, or if you tried to close an index, that's one of the actions you can perform. If you tried to close an index that was currently being written to, or some kind of race condition like that, you would first it would notify if you've configured those, but then it would wait the amount of time that you've defined as the retry interval, and then it would do that the number of times that you've specified as the retry count. So you could say, okay, retry this 17 times and wait 3 minutes in between each attempt. And then if it failed, it would notify. If it worked, you would get a notification as well.
Completion progress?
I don't know about progress as in like a progress bar, but yes, if you configured it to do so, you would get an alert. We have a number of outputs on our alerting plugin. You can even get a chime message, a Slack message, an email. There's also a webhook. So if you have some kind of microservice infrastructure and you want to hook into that, that's a possibility.
Thank you.
Just a small add-on to that. So you can also use explain API with the ISM policy that will give you exact state of this policy. So what's happening with the index will tell you when it was executed and it was completed as well. So you can go that way as well.
Thank you.
Does that mean state's an actual primary thing? You can come and see that?
Yeah.
This is
it's like a query.
Yeah, it is a query. It's an API query also.
Yeah. It actually relates to the question you were asking about, if you have a really intensive operation, sometimes people like to explain their queries. So if you've got a huge query, you can have it explain the query. And if you come from relational databases like MySQL or Postgres, there's usually a means to explain your query to make sure that your primary and foreign keys are lined up. You're not going into a row scan situation. Good question. Thank you. Yes, sir.
I'm very new to this. So let's say you took How Many I Shrunk the Kids and it started with shrink, and then the next step it failed. Does it roll back, or we just stuck with just shrink?
Well, it would, if it failed, I suspect it would, it would stop the job. And I don't think that it would actually make any changes as it was trying to shrink it, unless it was certain that it would work. But yeah, any kind of failure situation, it would notify you if you have that configured. And then it would go through the retry interval, retry count as many times as you have configured. But then it would not just simply break and leave you with a half rolled up index. Yes, sir.
Yes, since it's KubeCon, I should ask, do you provide any tools to manage this through infrastructure as code?
We do. So Eliatra, thanks Eliatra, they maintain our Kubernetes Helm chart operator. And so if you're a Kubernetes fan, yes, they maintain our Helm chart operator and have made many wonderful improvements to it. And of course, our open source nature is such that if there's some feature you need, please do file a ticket. And Chris, we run triage meetings all the time that happen in public. And so if you filed a ticket and you wanted to help triage that very ticket, you're welcome to join the meeting over Zoom to do that. And that's how Chris builds our wonderful communities that are in front of me here.
Maybe to add my take on it. So this would, in my opinion at least, not fall under infrastructure as code. Infrastructure as code is basically spinning up the instance, but creating an index or rolling over the index is more of an operational thing. It's not an infrastructure thing.
It's GitOps, so just code. I don't mind what's called.
The operator,
I define it through code.
operator as per docs operator allows you to create the ISM policies as well, and it will monitor them. So if you delete that inside the OpenSearch, it will recreate these monitors, those objects, so it will recreate that automatically. And also you can do the same with the index templates. So there's a few objects, so there is a lot of CRDs created with the OpenSearch operator. But that's in the docs, in the Kubernetes, in the operator docs, so you can go through that.
That's also a graph operator. Many options.
How'd I do? Am I doing good?
Very good.
Very good. Thank you.
Thank you, Nate.